Hey kids, welcome back to a math review. It's going to be a little sloppy tonight because I didn't have a lot of time to make this, but I wanted to put it together for you. Tonight our official target is simply, I can identify my Chapter 1 skill challenges, and work smart to prepare for this chapter test. A quick look at the vocabulary. I would review all these words: the distributive property, the associative property, the commutative, what the domain is over here in the X, and the Y. So I'm going to stop talking and let you look at that. All right, let's get going right into the properties. The first property is the distributive property. Go ahead and pause the video and try to rewrite these two expressions using the distributive property. Okay, take a look. Well, I have one set of parentheses up here. I can rewrite this as 7 times 3 plus 7 times 2. I can distribute out that 7 groups of 3 and 7 groups of 2. I can also go from one set of parentheses I can go from two sets of parentheses on top where I've distributed the 10 out, and I can group it. Instead of 10 times 3 minus 10 minus 2, I can take 3 minus 2 and group that all and take 10 times that. All right. Let's move on to the next target. That's 1.8a, the distributive property. 1.8b, the commutative power. Commuting allows us to move numbers around. As long as it's all addition or all multiplication, you can move the numbers around into any order that you want and perform the operation. So go ahead and pause and rewrite these two expressions. Okay, well, there may be other ways you can rewrite them, but I thought the smart thing to do would be to move the 11 close to the 289 because these are compatible. That would make 300. Over here, I would want to move the 4 next to the 25 because 20 times 5 times 4 would be 100. So there are other ways as long as you kept the same three numbers and you took and moved them around. That's what the commutative power. Mrs. Crothers commutes to and from work. This allows you to commute numbers when you're using all addition or all multiplication, just like moving back and forth to work, commuting. All right, that's 1.8b. 1.8c is the associative power. Associative power is the grouping power. Go ahead and take a look at these two examples and see if you can rewrite them. All right. Well, as long as you don't change the order, 289, 11, and 36, you can move the brackets around. Now, commuting power, our previous target, allows us to move the numbers, but in its pure sense, the associative power is just moving the groupings. So here, I just move the brackets over here. I can do that because these are all addition. 25 times 17 times 4. I can move it to 25 times 17. Notice the order has not changed. The associative power doesn't allow us to move the order, but when the operations, multiplication and addition, there are a number of those all in one line and they're all the same operation, it allows me to select different groups in order to complete my problem. All right, 1.8d is evaluating the expressions using them. Let me just throw a screen on here quick, and why don't you go ahead and try evaluating these expressions using the powers. Go ahead. All right, let's see how you did. Well, first thing I did was I moved some numbers around, it looked like. So I moved the 11 and the 289 together. So I used my commutative power to regroup or to move it, and then I grouped using the associative power. So I got my compatible numbers here together, and I have these two are compatible numbers. So easily in my head I can do 340 to get 340. Otherwise I would have probably had to add these, on the side of, on scratch paper or something. Over here I did the same thing. It looks like I moved some numbers. I'm going to change this. This is supposed to be 4. I had 25 times a quantity of 17 times 14 times 2. I didn't know what that was, so I commuted this 4. I moved it. So I had 25 times 4 times 17 times 2. That gave me 100 times 17 times 2. 100 times 17 is 1700 times 2. And 34. You start to apply the order of operations when you do this, but being able to group and move numbers around allows you a lot of flexibility, so you don't have to always get your calculator out or work on scratch paper to solve your problems. So, all right, let's keep moving here. 1.8d, it's going to get a little noisy because the bell just rang here, but you just stay with me. 1.8d, again, evaluating these expressions using powers. Go ahead and try it. All right, let's see how you did. Well, I use the distributive property here. I don't know what 5 times 15 is, but I know what 15 minus 4 is. So I took and put the 5. I went from 2 sets of brackets to 1, and I have 15 minus 4 in the middle, which I know 15 minus 4 is 11, and I know that 5 times 11 is 55. So there I solved that by using the distributive property. I went from 2 sets of parentheses down to 1. Allowed me to work easy. I don't know what 8 times 23 is. So what I did was I grouped, I distributed that 8 out. I do know what 8 times 20 is. So I went from 1 set of parentheses up here. I broke that down into 2 and distributed the 8. So I have 8 times 20, and I have 8 times 3. I know what both of those are. So that's 160, and there's 24, giving me 184. All right. The next target, domain and range. Go ahead and pause the video and see if you can identify what the domain and the range is of each of these charts. Okay, I'm back. This is the domain, the x function, the n. These numbers, this would be the range. Domain, range. X, y, in, out, domain, range. Domain, range. Are you getting sleepy? Domain, range. All right. Next, complete this function table, 1.10c. You have to be able to figure out what the rule is and put it in. Go ahead and pause the video, see if you can figure it out, and try these 3 examples. Let's see how you did. All right, you did identify that this rule is adding 7, so I can pop 50 in here. 50 plus 7 is 57. 60 plus 7 is 67. 51 plus 7 is 58. Good, my rule works. I checked those different variables. This one here, it's x minus 3, so I think it's 76. Let me check my work. 35 would be my x, so 35 minus 3 is 32. 76 minus 3 is 73. 45 minus 3 is 42, and so on. That one worked. This one here was x times 7. So let me put this in here. 8 times 7 is 56. 3 times 7 is 21. 5 times 7 is 35. So that worked too. All right, let's keep moving. 1.10b1. On this one here, what you need to do is write a 2-variable equation for a function table. And this is the way to look on the test. You can have some answers over here. Why don't you go ahead and pause it and see if you can find the answers to these 2 problems. All right, I'm back. Well, these ones here are a little complicated. I really wasn't sure what to do with them either because it's kind of hard going from 3 to 34, 8 to 74. So sometimes I work backwards and I just start. I'm going to put 3 into this one here. 3 times 8 is 24. 24 minus 11 is not 34, so it can't be this answer here. So I'm just going to grab one and cross that one off. Try the next one. If I put the 3 in, 3 plus 8 is not 34 either, so it can't be this one here. Remember, it has to work for all the variables. Let's try k times 8. So 3, if I put the 3 in, 3 times 8 is 32. It didn't work for that one, so it can't be that one. It looks like it must be D, but let's just try it. If I put the 3 in, and I'll just type a 3 and throw that in, 3 times 8 would be 24, plus 10 is 34. Let me try it with 8. If I got rid of that and I put in 8 times 8 would be 64, plus 10 would be 74. So our correct answer here is D. And I worked backwards to solve that. So don't forget that strategy. That's a good one. This one here, 6 to 51, 4 to 33, I have no idea. So I'll start at the beginning. Let's put in 6. 6 times 9 is 54, minus 3 is 51. Well, I might have got the jackpot on the first one. Let me try this one. Put the 4 in. 4 times 9 is 36. Minus 3 is 33. It looks like this is the correct one, but I'll go through and double check these other ones. 6 times 9 is 54. Plus 2 is not 51, so it's not that guy. 6 times 9 is 54. Minus 6 is 48. Can't be that guy. Put in the 6 here. 6 plus 3. No, that's not 51. All right, so by process of elimination and plugging in the different variables, I found that that is the correct 2-variable equation. All right, finally, write a 2-variable equation for this word problem. I'm sorry I couldn't find new word problems. I just had to throw this together quick for you. But rule number 1 when you're doing these, draw a table. Rule number 2, put y equals down at the bottom so you keep in mind those are your 2 targets. This is where your equation will be. So let's just run through this. Between Hiroshima and Kokuro, Japan, a bullet train averages a speed of 164 miles per hour. This is the fastest scheduled train service in the world. Make a function table that shows the distance traveled at that speed in 1, 2, and 3, and 4 hours. So we'll just put in 1. We're not going to do 2. We'll do 2. We won't do 4. We'll just do 3. All right. So if it goes 1 hour and it goes this fast, it's going to be 164 miles, right? If it goes 2, I could get my calculator out here and take 2 times 164, and that would be 328, it looks like, 328, and so on. But now I'm stuck with going, what's happening between 1 and 164? What's going on in this function that allows me to go from the number 1 to 164 and the number 2 to 328? How did I get there? Well, I was taking that x value times, sorry I have to use x again, times 164. And that looks kind of weird, so I'm just going to change that to 164x. So whatever the x value is, times 164. So in this case, it's 1. Therefore, when this is all said and done, I can write my equation by looking here. The y is equal to 164x. 164x. Okay? And one other problem for 10.10b2, writing this 2-variable equation. The technology fee for your pager service is $22 a month. Make a function table that shows your total charge for 1, 2, 3, and 4 months. Again, we're focused on writing the table here, so in the equation, not solving the problem. So we're just going to go 1 month, 2 months, 2 months, and 3 months. All right, the first month is going to cost $22, right? And then if they had it for a second month, will be 22 plus 22, right? So that's 44. And the third one would be 66, right? So when you look at it, you got to ask yourself, well, if you can complete that table, you should be able to figure out how did we get from 1 to 22 and then 2 to 44. Well, you're right. It's whatever this x value is, which is 1 or 2 in this case, times the x. So our rule becomes 22x, or x times 22. Either way, it's the same thing. So 1 times 22 is 22. 2 months times 22, or 22x, is 44. So our equation for this one, I'm going to slide it over here to make sure it shows up, will be y equals either x times 22, or the way I like to write it, 22x. All right, that's the Slam Bam Thank You review. I hope I didn't make any mistakes doing it. I got a little jammed up on my prep today, but I want to make sure I gave you an opportunity to listen to me review all the targets with you before the test on Monday. All right, good luck. Thanks for watching.